హాయ్ ఫ్రెండ్స్, ఈరోజు మనం హెర్ట్నల్ గవర్నర్ గురించి చూద్దాం. హెర్ట్నల్ గవర్నర్. ఓకే, ఈ గవర్నర్ ఎలా ఉంటుందో చూద్దాం ఇప్పుడు మనం. హెర్ట్నల్ గవర్నర్ ఈజ్ ఏ స్ప్రింగ్ లోడెడ్ గవర్నర్ యాక్చువల్లీ. ఓకే, సో ఈ స్ప్రింగ్ లోడెడ్ గవర్నర్ అంటే ఇక్కడ ఎక్స్ట్రాగా మనకి ఇప్పుడు స్ప్రింగ్ అనేది యాడ్ అవుతుంది మన గవర్నర్లో. సో దీని సెటప్ ఎలా ఉంటుంది అనేది ఇప్పుడు మనం చూద్దాం. ఫస్ట్ ఆఫ్ ఆల్ okay, and now you are going to take some another axis in here. Like this. Okay, so first I am going to fix in here on spindle. Okay, we know very well about this is having a spindle. Okay, it's going to continuous on top also. Like this. Okay, one spindle is there, and now here I am going to fix ball rollers masses. Okay, two balls ఉంటాయి కదా, ఇప్పుడు ఆ టూ బాల్స్ని మనం ఇప్పుడు ఫిక్స్ చేసుకుందాం. సో ఫిక్సింగ్ ఆఫ్ టూ బాల్స్ ఇన్ హియర్ we are going to take, this is the axis first. Okay, and this axis we are going to take, and then here I am going to fix some metal. And now here is going to see. This is also having shafts. You can imagine this is also has shafts. Okay, so this is another one, so you can take opposite direction I think. This one part and this is another part. Okay, here I am fixing roller. Okay, thus so I am taking this point is called R, and now here too, here I am going to fix in one point is here. I am going to take this distance is called Y. Okay, now this is called R, is called roller. R is called roller. Okay, then now I am doing here one lever. It's going downwards, fully downwards like this. Okay, and then here also we are taking. So here is axis. ఈ యాక్సిస్లే మనకి మోస్ట్ ఇంపార్టెంట్ థింగ్, గుర్తుపెట్టుకోండి. ఎందుకంటే ఫ్రీ బాడీ డయాగ్రామ్ చేయాలన్నప్పుడు మనకి ఈ యాక్సిసే బాగా ఉపయోగపడతాయి. ఓకే, అండ్ దెన్ నౌ ఇన్ దిస్ లివర్ ఐ ఆమ్ అటాచ్డ్ వన్ బాల్. ఓకే, ఐ am going to attach one ball B. So here to here distance is called X. So this is Y and this is X. This is point O. The central point is called O. And now, okay, we are going to give this name. This is called bell crank lever. This is called a bell crank lever. Okay, and then now we are going to see. Okay, here I am going to draw another side similar diagram. Okay, this similar diagram I am going to draw here also. So you know very well this axis means ఇక్కడ ఏదైతే షేప్ సైజ్ ఉన్నాయో అవే షేప్ అండ్ సైజ్ ఆల్సో కమ్ టు హియర్ ఆల్సో. దట్ ఈస్ కాల్డ్ ఏ మిర్రర్ ఇమేజ్. ఓకే, లైక్ దిస్. ఇక్కడ హ్యాచింగ్ ఎలా ఉందో అలాగే సిమిలర్ హ్యాచింగ్ చేసుకుందాం. ఎందుకంటే దిస్ ఈజ్ ఆల్ ఆర్ వన్ పార్ట్. And now here is having hatching like this. This is opposite direction but similar part. These all are having circular parts, remember this. Okay, and then this one is called coming to here like this. Okay, so now here I am going to fix one roller here, and this roller is going to pass like this, and we are going to take some point O. So then here O point you are going to give some axis line, and then here. So this is the same equal mass. Okay, equal mass length. So this is called B. Okay, and now this is called R, and now this is called bell crank. So this is point O. Okay, now here is coming from, this is called sleeve. This is called sleeve, and then here the top of portion is called collar. Okay, this is sleeve and this is collar rollers. Okay, right. And now we are going to, here we said Hartnell governor is spring loaded governor. Okay, so I am going to fix in here spring. I am going to fix spring. We are going to take number of springs like this, and then here is going to finish with the help of cap nut. Now this is spindle shaft. See this. Okay, so this is spindle shaft, and then now here this is called spring. I am going to fix here adjustable nut. So this is called here I am going to fix adjustable nut. So this name is called here nut. This is called frame. So this is ball. Okay, so this is the total setup of Hartnell governor. Okay, and now we are going to know about all those things in here. The spring force may be adjusted by screwing up or down on the sleeve. ఈ నట్ అడ్జస్ట్ చేసుకోవటం వల్ల మనకి ఏంటంటే ఈ స్లీవ్ అనేది అప్ అండ్ డౌన్ మోషన్ అనేది మూవ్ అవుతూ ఉంటుంది. ఓకే ఓకే నెక్స్ట్ హియర్ వచ్చేసరికి ఏంటంటే ఈ 2 balls వచ్చేసరికి మనకి సేమ్ ఉంటాయి. సో లెట్ వీఆర్ గోయింగ్ టు సీ ఇన్ హియర్. ఫస్ట్ స్మాల్ m is called here mass of each ball in kg. Okay, mass of each ball in kg. Then here capital M, so that is equal to mass of sleeve in kg. సో ప్రీవియస్ మనం నేర్చుకున్నది సేమ్ పోర్టల్ గవర్నర్కి అలాగే రోయల్ గవర్నర్కి మనం ఎలాగైతే చూసుకున్నామో ఈ బాల్ మాస్ ఏదైతే ఉందో దట్ వీ టేక్ కన్సిడర్ స్మాల్ m. Here sleeve have some mass, so that mass you are consider you are going to capital M. Then we are going to see R1. So okay, and what is this R1, where it will come, we are going to see in minimum and maximum diagrams. That is called a free body diagram. First we are going to consider all those things. That is called maximum radius of rotation in meters. Then R2 is equal to maximum radius of rotation in meters. Now then omega 1 is equal to angular speed of the governor at minimum radius in radians per seconds. Then S1 is equal to spring force extracted on the sleeve at omega 1 in newtons. Spring force extracted on the sleeve at omega. So spring force extracted on the ikkada sleeve paina okay edaithe untundo adi. And next S2 is equal to spring force extracted on this sleeve at omega 2 in newtons. So then Fc1 is equal to centrifugal force at omega 1 in newtons. So centrifugal force Fc is equal to m into omega 1 square into r. Okay, and then now here we see Fc2 is equal to centrifugal force at omega 2 in newtons. Then that is equal to m into omega 2 square into r. Okay, and now we are going to see S is equal to stiffness of the spring. Stiffness of the spring, or the force required to compress the spring. Force required to compress the spring by 1 mm by 1 mm, and x is equal to length of the vertical or ball arm of the lever in meters. Then y, small y is equal to length of the horizontal or sleeve. One is ball and another one is sleeve. Look at this, here to here sleeve, horizontal, and here x is equal to ball. Okay, see this ball height x, and this is sleeve length, horizontal length. Okay, okay, sleeve arm of the sleeve limb of the lever in meters. And now here r is equal to distance of fulcrum O from the governor axis or the radius of rotation. When the governor is in mid position in meters. Okay, now we are going to see these all are things where it will come. So now we are going to see in here maximum and minimum position of the governor. Okay, so I am going to draw first my minimum position. So now this is having central axis. And then now we are going to see here is one axis is there. And another one axis. Okay, so this is the point, and now here I am going to fix first O point is in here. So this is axis, this is axis, this is axis. Similarly I draw like this. Okay, this is the O point and this is O point. And now here I am going to draw a ball. This is bell crank lever, we just consider that. So here is having ball. So this is point B. This is called centrifugal force 1. And now here is acting small mg. Okay, small m g, and now we are going to see from O to ball center point is the distance is called, take A1, and then this axis to center point B is called, take R1. That is the minimum radius of rotation in radius. This is R1. Okay, sorry, maximum rotation. So this is called maximum rotation R1, and then this is called R. R is coming distance of fulcrum O from the governor axis. So this is called a governor axis. So this is called a governor axis. Okay, now we are going to see here is angle is there. So I am going to put this angle is called theta 1. This angle is called here theta 1. Now ball part is over. We are going to see here exact perpendicular line I am going to draw. This is 90 degrees, and now here is applying point. Okay, so here to here distance is called y. At the same time here, look at this, here to here distance O to B distance is called x. So O to B, this distance is called x. So this is y1, and now here O to R distance is called y. So this is, I put it R, then it will come y. So this is x and this is y. Okay, and now Then we are going to see in here, this is R1, I take it. Okay, and now the height, here we need height. Just observe this. We take height, h1 is this. Okay, so here you see this is perpendicular axis. This is the perpendicular distance in here. So this perpendicular distance we are going to rotate like this. Similarly, look at this, this is rotating. So that's why we are getting here h value, h1. Okay, and now we are going to see, here is having one angle. So similarly this is also coming theta 1. ఇక్కడ ఎంత యాంగిల్తో ఏదైతే రొటేట్ అవుతుందో సేమ్ అదే యాంగిల్తో ఇక్కడ కూడా మనకి రొటేట్ అవుతూ ఉంటుంది. వై? బికాస్ దిస్ ఈజ్ ఎల్ సెక్షన్. ఓకే, అండ్ నౌ ద మెయిన్ పాయింట్ ఇన్ హియర్ ఈజ్ హ్యావింగ్ the load is acting. In previous we know very well that is called W by 2. Here W by 2 plus S. So W by 2, capital W is equal to M into G. Okay, plus S1, that is called minimum. So divided by 2. Divided by 2. Okay, this is the total minimum position. Minimum position. Okay, so this is the diagram for minimum position of the Hartnell governor. Now we are going to see maximum position. Okay, right, we are going to see now maximum position, and then here also I am going to take some axis like this. And now here also governor axis is there. This is called governor axis. Okay, so now here this is called governor axis. Now the point is called here O. Okay, O is coming here, and then now you can rotate this some angle. This is the point R we take. Then this angle is called here theta 2, and then this distance is called Y, and axis to this one is called Y2. Here we put Y1, and then here is coming from Y2. Okay, and perpendicular axis, then we are going to draw here also exact 90 degrees. We are going to project like this. Now this is the point is called ball B, and now here this is coming from MG. What is angle in here? This is also theta 2. ఇక్కడ ఎంతైతే యాంగిల్ రొటేట్ అయిందో సేమ్ యాంగిల్ you can rotate in here also. So then you know very well the perpendicular force is vertical force is acting, capital M into G, so plus S2 divided by 2. see here S1, and coming to here is also can take S1. This is also can take S1. Okay, now we know very well this is the distance is called R. See here, R, axis to axis, O point to governor axis distance is called R. O point to governor axis distance is called R. Okay, that is very clear. And then now here the point O to B is called A1. So O to B, so O is in here, and then okay, I'm going to draw like this. This here to here, the distance is called A2, and then ball to governor axis, what is the distance? This is ball B to governor axis is called R1, and then we can put it here R2. Okay, so now this is Y, so this is called X, and now this distance, see here to here distance is called X2. This is Y2, this is X2. So similarly we are going to draw here also the point O to B is called X1, O to B, so O to B is called X2. Okay, so where the point is touching here, we are going to draw one horizontal axis like this. And see the difference in here. Here to here distance is called O2, this axis is called H1, and then now here O is there and now R is there. So what is this distance is called? We can take this distance is called H2. So this is H2 and this is H1. So total the difference between this means is called H. Okay, now this is perpendicular distance, height. This is perpendicular height. Okay, so we call this name is called here B, maximum position. Okay, this is called a maximum position. Okay, clear? Right. So this is the diagram. First we need to draw this diagram before going to calculation. So we are going to performance of this governor. So now I am going to take first picture A, minimum position, and then now here I am going to take the component H1. So this is called H1 distance. This is H1 distance. Okay, that is equal to A1 by X. This H1 divided by Y is equal to A1 by X. Why? Because this is the triangular, and that is equal to A1. A1 is equal to, how can we write? R minus R1. This is X for this distance. Okay, and now here A1 is equal to total distance is R, that minus R1. Okay, so now here I am written H1 divided by Y is equal to A1 divided by X. So that is equal to r minus r1 by x. And similarly we are going to figure B. So this is A. We are going to take figure B. h2 by y is equal to a2 by x. So then is called here r2 minus r divided by x. See here, a2 is equal to r2 minus r. Este manaki ee distance vastundi. Okay. Now adding equation 1 and 2. So can put here 1. Take this is 2. Okay, then add this both. What happened we will see. h1 plus h2 divided by y is equal to r2 minus r1 divided by x, or h by y, that is equal to r2 minus r1 divided by x, since h is equal to h1 plus h2. Okay, that's we know very well. We are going to see here h is equal to h1 plus h2. So now for minimum position, so taking moments about point O, we get what happened, m into g plus s1 divided by 2 into moments తీసుకోవాలి కదా, ఇక్కడ చూద్దాం. This is the point and this is force is acting. This force in perpendicular distance is y1. So mg plus s1 by 2 into y1. So that is equal to, so this force is acting in reverse direction, so then we are taking that thing, and now here fc1 into x1. fc1 into x1 minus m into g into a1. Look at this one. Okay, this one is called here mg, the distance is a1. This is acting vertical, so this distance and perpendicular distance a1, force into distance. Okay, so this is the moments. Now here we are going to see m into g plus s1 is equal to 2 by y1 fc1 into x1 minus m into g into a1. Okay, so again maximum position taking moments about O. So this is minimum position. Now we are going to take maximum position. So maximum position taking moments about point O. So we get m into g plus s1 divided by 2 into y2, that is equal to fc2 into x2. So here is coming from this fc2. Okay, x2, and now plus m into g into a2. Okay, look at this. This is m into g, that is coming from a2. So axis perpendicular distance, this is the axis key. ఇది చూసారా, యాక్సిస్ కీ పక్కన ఉంది కాబట్టి మైనస్, ఇది యాక్సిస్ కీ పక్క వచ్చింది కాబట్టి ఆటోమేటికలీ ఇట్ విల్ టేక్ negative direction. So it will have that the thing is coming from here, the force is acting anti-clockwise direction, and then here also anti-clockwise direction. So both are in plus. But in here we see this is clockwise direction and then this is anti-clockwise direction. That's why Fc minus Mg. These both are in same direction, anti-clockwise direction. That's why Fc2 plus Mg. Okay. Right. So now calculate this. M into G plus S2. So that is equal to 2 by Y2 into Fc2 into X2 plus M into G into A2. Okay, so then I put it here. This is fourth equation. And yeah, now this is I put it here, third equation. Okay, so ఇప్పుడు సబ్స్ట్రాక్ట్ చేద్దాం. So subtracting equation 4 from equation 5. No, we can take 4. So then we are going to see here S2 minus S1 is equal to 2 by Y2 Fc2 into X2 plus M into G into A2. That's the minus 2 by Y1 Fc1 into X2 plus X1. Okay, this is minus M into G into A1. Okay, so then here we know that S2 minus S1 is equal to H into S. So and H is equal to R2 minus R1 Y by X. So S is equal to S2 minus S1 by H. That is equal to S2 by S1 divided by R2 minus R1 into X by Y. Okay, so this is the formation. So then this is important thing, spring, and now here A2 means this is the thing. Okay, so neglecting the obliquity effect of the arms, that is x1 is equal to x2 is equal to x and y1 is equal to y2 is equal to y. ఈక్వాలిటీ అనేవి ఉన్నాయో అవి మనం ఇప్పుడు నెగ్లెక్ట్ కనుక చేసుకున్నట్లయితే and the moment to weight of the balls, that is mg, we have from minimum position m into g plus s1 divided by 2 into y. So that is equal to fc1 into x లేదా m into g plus s1 is equal to 2 into fc1 into x by y. You can write anything. Okay, so you can put it, this is one equation. Okay, so now similarly from maximum position you can take maximum position, you can take m into g plus s2 divided by 2 into y, that is equal to fc2 into x లేదా m into g plus s2, that is equal to 2 fc2 into x by y. So here also 2. This is 2. Okay. Yes. Now this you can take one equation. Now this is called 6. So subtracting equation 5 from equation 6. Okay, so then S2 minus S1 is equal to 2 into FC2 minus FC1. So then that into x by y. So we know that x2 minus s1 is equal to h into s. So and h is equal to r2 minus r1 into y by x. So that s is equal to s2 minus s1 divided by h. Then 2 into fc2 minus fc1 divided by r2 minus r1 into x by y whole square. Okay, so this is the equation. So here మనం గమనించాల్సింది ఏంటంటే unless otherwise stated, the oblique effect of the arms and the moment due to the weight of the balls is neglected in actual practice. When friction is taken into account, the weight of the sleeve mg may be replaced by mg plus or minus f. The centrifugal force Fc for any intermediate position, that is between the minimum and maximum position at the radius of a rotation r, may be obtained as discussed below. Since the stiffness for a given spring is constant for all position, therefore for minimum and maximum data position S is equal to 2 Fc minus Fc1 divided by r minus r1 and x by y whole square. For intermediate and maximum position, S is equal to 2 into Fc2 minus Fc divided by r2 minus r1 into x by y whole square. So now this is put it one equation and this is put it one equation. What is the last equation is you can take here 6. So this is take 7 and this is take 8. Okay. And now we take this thing is coming from 7, I think. So this is 8 and this is we take equation number 9. Okay, so therefore from equation 9, 8, 7, Fc2 minus Fc1 divided by R2 minus R1 is equal to Fc minus Fc1 divided by R minus R1, that is equal to Fc2 minus Fc divided by R2 minus R. So that means here Fc is equal to Fc1 plus Fc2 minus Fc1 into R minus R1 divided by R2 minus R1. So that is equal to Fc2 Fc1. Sorry, Fc2, sorry, here Fc2 minus Fc2 minus Fc1. So then that is into R2 minus R2 minus R1. So this is the final thing. We can calculate this thing. Okay, yes. Centrifugal force Fc is equal to. Okay, this is the performance of the Hartnell governor. In next class, we are going to discuss problems on this. Okay, thank you.